Okay, hello again. I'm Miss Awinup, your grade 10 maths teacher. Welcome back. In today's lesson, or in our last lesson, we looked at using the quadratic formula to solve quadratic equations. Okay, in this lesson today, we are going to look at graphing, okay, graphing quadratic functions, okay. All right. Now, if you will remember our lesson when we looked at graphing linear equations, we started off with a table of values. Now, very similar, that is what we are going to do. We'll start off with a table of values. We need values for x and y because in order to plot a graph, you need x and y points to mark out on your Cartesian plane and then draw your graph, okay? So, we will do an example. Let's look at the equation y equal to x squared. Y equal to x squared, okay? So, we draw up our table of values and we are going to have x ranging from -3. Okay, so -3 all the way up to +3. Okay, 2, and we have x equal to +3. Okay, so using our equation y equal to x squared, we are going to substitute into the equation. So if x is -3, okay, then -3 will be squared to give us 9. Okay, if you notice, you will see that after 0, the numbers are repeating itself. Now, when we draw the graph, you will see y, or you will see the result of these repeating numbers here. Okay, so let's see. We'll draw our Cartesian plane. We have the highest value on the y-axis is 9. So let's make put 9 at the very top. Okay, so we have 9. Right. So here is our Cartesian plane. We are using all 4 sections of the Cartesian plane. Okay, now to draw your graph, okay, you are going to plot the points. So our first point is -3, +9. So the next point is this, and so on. Okay, so -3 and +9. Okay, here's the point. Then we have -2 and +4, which is here. -1 and +1. Then we have the point 0, 0. Okay, then 1, +1, 2 and 4, and 3 and 9. Let's see. Okay. All right. We're going to connect the points and let's see how our graph looks. Here we go. And we have a turning point at this point here and back up in this direction. Okay, so this is the graph of y equal to x squared. Now, for any quadratic function, all right, the graph is a curve and it is known as a parabola. All right, a parabola. Okay. Now, there are special features about the parabola, And the equations have a very big effect on how the graph looks, or how the parabola looks on your Cartesian plane. Okay, so this is y equal to x squared. If you have the equation y equal to negative x squared, where coefficient of x squared is negative, then your parabola is going to be upside down. Mirror image of the first one, but y equal to negative x squared. Okay, now if your equation, all right, is, say, y equal to 2x squared, where the coefficient of x squared is greater than 1, then your equation is going to be narrow. So x squared is here, this is equal, x coefficient is 1. But if it is greater than 1, then our graph is going to be narrow, like that. Okay, so this is y equal to 2x squared. Okay, it is narrow. However, if that coefficient is less than 1, this time the graph is going to be wider. All right, it will come through here, again through the origin, but it will be a wider graph. Okay, so y is equal to half x squared. So see how the equation is affecting the parabola? If it is negative, the graph is, what we say, it is convex or upside down. Okay, if the coefficient of x squared is greater than 1, we have a narrow parabola. If it is less than 1, the graph is going to be wider or broader. Okay, now sometimes if your equation has a constant added on, okay, now this one we have plus 2. So x squared is here, all right, in blue here, but this time constant 2 is added. Now what does the constant do? It moves your parabola up and down the y-axis. Okay, so if it is plus 2, the turning point here is not going to be at the origin anymore. It's going to move 2 places up. Okay, so this time, let me use another color so you can see this clearly. This time, x squared plus 2 will now be coming in the same, all right, but turning at this point and going up. So y equal to x squared plus 2. You can see now the turning point has moved from the origin up to positive 2. Okay, now what if we had y equal to negative x squared, but this time minus 3. Minus 3. Okay, coefficient of x squared is negative, so we know that the graph is going to be convex, and we have a constant of negative 3, so that means the graph will be down here, turning point at negative 3, like that. Y equal to x squared minus 3. Okay, so very interesting how the equation affects the parabola. Now with these features, you should already know when you're given an equation how the graph should look, whether it's going to be concave or convex, whether it will be narrow or broad, okay, and whether it has a turning point at 0, 0 or along the y-axis. Okay, now a few things that are important that we need to remember about the parabola. Okay, where you have the parabola that is convex, okay, we say that the turning point here, the turning point, all right, the turning point is maximum, all right? Or maximum turning point, meaning that the y values are at the highest point here, or highest value of y, okay, is up here, and therefore it has a maximum turning point. Now, if your parabola is concave, all right, then the turning point is minimum. Now, if you are thinking logically, then you should already know that if maximum is a high y value, then minimum will be a low y value. So you can see minimum value of y at this turning point is 0. That's why it is referred to as a minimum turning point. Okay? Now, the last important thing we need to remember about our graph is where the axis of symmetry is. Okay? The axis of symmetry lies at the point where the graph turns. Okay, so the turning point is where we find the axis of symmetry. For all the graphs that we have seen here, the axis of symmetry is at the line here, which is the y-axis. Okay, so our examples show that the axis of symmetry in all cases is the y-axis. Now, sometimes the graph will move, but we will look at that later. So this brings us to the end of our lesson. I hope you have learned something new. Okay, I hope you have learned something new. We have our tables, okay, using the table to transfer to the Cartesian plane, and the different features that we find on parabolas. Okay, thank you for joining me. I hope you've had fun drawing graphs with me. I'll see you in the next lesson, where we are going to look at a faster method of drawing the parabola. Thank you.